Hi, this is a video to show off the new Stochastic height blending node for the material graph in Unreal. And as an example here, I have a very simple landscape material set up, and you can see that there's a lot of tiling going on. This is actually a very nice texture. It has a lot of nice details, but it's being made quite unusable by the fact that it tiles all over the place. So let's fix that. I'm going to open up my material instance here. I'm going to shrink this so we can see the difference. And then I'm going to turn on the stochastic sampling for it. And there we go. You'll notice that you really can't see it tile at all. If I go in close, you still have that nice detail. All those rocks and water and stuff is very present, yet you don't see any tiling whatsoever. So first I'm going to explain the options that I've exposed on this material, and then I'm going to show you how it gets used in the material graph. Basically it works just like a texture sampler. But I've exposed a couple of the options here so that we can see the difference. The first one I'm going to talk about is use luminosity. Right now I'm using a height blend operator to blend these values, and I'm using a height map that happens to be stored in the alpha channel of the diffuse or albedo texture. So that works really well, but maybe I don't have height maps available, so I could use any channel of one of my textures, or I could use, if I don't have any of that, I can use the luminosity and use that to generate the value. So if I turn on use luminosity, then basically it's going to use the luminosity of the albedo texture as the height input effectively. And you'll notice that this has a different result. It still looks great. But in some ways it's nicer in that it seems to preserve more of the water. Now the reason for this is that the luminosity here is being used instead of the height, and when you use the height, all of the water is going to be in the low areas, and so using the height, the rocks are going to win out over the water more often, and so you'll end up with a little less water. And you can use whatever data you want. You can author special textures for this, whatever you want. But I find using either height data or luminosity data works very well, and that prevents you from having to author additional data that you might not have. So I have two of the parameters available here. The first one we're going to talk about is the contrast. The contrast controls how sharp the blending is, basically how wide the area of blending is. So if I have this very low like it is right now, it's at 0.15, then you're going to get some very tight blends between the different samples of the texture, and that's going to create a very sharp and detailed look like the original. If I crank this up, you're going to see a much softer blend now, where some of the water sort of gets blended out, and it's a much softer look. So that's basically what that controls. I personally like it kind of low so that you kind of retain more of the original texture. And then there's a scale parameter here. Now the way this technique works is that effectively what it does is construct a grid of virtual triangles, and it offsets them with some noise so that they're all sort of randomly placed and arranged, and then it samples 3 of these triangles for each pixel, and basically that gives you some randomization of which texture, and then it blends those together using a height blend operator in this case. So what this scale controls is how large, like how much of the texture will it construct these triangles, how big are these triangles. So if you were to set this to like 0.01, then effectively over the course of one tile of the texture you would have 100 little tiny micro triangles that it's displacing around. So the problem with that is then you would get very little of the original texture, and it would synthesize into kind of just a wash of the original texture data. And if you made it really, really large, like let's say we set it to 10, then you might see the texture tile 10 times in one of these virtual triangles before it actually breaks it up. So, if you turn this way up, I have it limited here. At 1.5, it's going to use up to 1.5 tiles of the texture, and at 0.5, which I have at the minimum, it will use essentially 2 triangles per texture tile. I personally like this around 1.2 because I find that gives you a little more of the texture information. Like you might theoretically see a tiny bit of tiling, like 1.2 of the texture, but that is not enough to really catch my eye, and it retains a little more of the original detail of the texture. So now let's open up a material and see how this actually works when you're in the material graph. I have two examples in here, one for landscape and one just a regular old material. I'm just going to load the regular material one for now because it's a little simpler than a landscape material is. So we'll open this guy up. And the way this works is instead of using a sample 2D node, you would use the stochastic sample 2D node. And this looks very similar to a regular texture sampler node. It takes a texture input, a UV, and then it has a scale and contrast settings for you here. So if you want to drive those with an exposed parameter like I've done, or if you just want to hard code them in the shader, you can do that. So that's really all that's new versus a traditional texture sample. And then you have your outputs here and a special output for the blend weights. And so this is the result of the blending. And so in this case, I have in my albedo texture here, I have the height in the alpha channel. And so I am blending here based on that height channel. So if I go to my parameter details here, and I need this node selected, and I come down here, we can see that the height channel is set to the alpha. So I can set this to the red, green, blue, or alpha channel if I would like to pull that from a different channel. I might pack height in with, some other data like the specular or something like that. Then what we do is we have another sample here for the normal map, and we chain the blend weights into the blend weights input here. And when we do that, that means it's going to get the scale and contrast from this, and it's also going to get the result of the blending from this node, and use that for this one, so that our blends all match up between each texture. Now you could each have them blend on their own data or whatever if you wanted to, but usually what you want is that they all blend the same. So that's how you chain those together, and then you just take your normal map here, and then in this case I have a smoothness texture which has ambient occlusion in the alpha map, and the smoothness is in the green, and I sample that again with the same blend weights, and I turn it into roughness with a 1-, and then plug in the ambient occlusion from the alpha channel. So it's just like setting up a normal material and using a normal texture 2D sampler. Basically works the same. So yeah, I hope that explains it all. This is going to be available on the asset source soon, I hope, and or the marketplace. You can tell I'm from Unity land. But anyway, this will break up tiling on surfaces in a really wonderful way. I hope you get some use out of it, and it solves your tiling problems, because that's what it's meant to do. Now one more thing I should talk about is comparison to the original version of this. There is a paper going around by Eric Heinz, and an implementation that Unity actually did of the paper that is called Stochastic sampling with a stochastic sampling of procedural textures with a histogram preserving blend operator. It's a lot of words. The difference between this and that paper is what they actually required was pre-processing the textures into a custom format, getting some lookup tables, and then when they did the blending, they would attempt to preserve the histogram of the image. And this works out pretty well, actually. But what I found was that it was slower in the shader, it required custom texture formats, it actually required you to decode things differently depending on the texture compression format used. So it added a ton of complexity, and the pre-processing of the textures was not particularly fast, taking several minutes sometimes. And so I came up with this technique because it basically doesn't require any of that. And I actually find the results to be better in this technique than the original. They tend to preserve the original texture's intent more than the original one. The original paper tended to kind of blur them out. It blurs because it's trying to maintain that histogram. It's not really trying to use chunks of the original image. And this limits the blending based on that contrast setting, so that you're only blending right along the edges of where the textures of these virtual samples meet. So yeah, I hope this has been useful, and yeah, thanks a lot.